Hello. We're excited to share our work at Astrus with the attendees at DAC 2026. Astrus is building automated analog layout. I'll share why analog design is important and how we are approaching solving the analog layout problem. Digital design has had decades of EDA automation and productivity gains, while analog design has limped along at the same pace for years and is still largely built by human hands. The reason this matters is that increasingly, analog is where the cost and time to market actually lands. First, let's look at cost. Analog design effort is disproportionate to its makeup in terms of the number of transistors in the overall industry. A relatively small number of transistors soak up a significant portion of the budget. Analog, or AMS, accounts for only 1/40th of 1% of transistors manufactured, but that proportion balloons to almost a quarter of total design cost. This asymmetry of cost is due to the bespoke and hand-tuned nature of analog design, in contrast to the efficiency of automated digital design. In addition to disproportionate cost, the analog design, layout, and verification cycle is the long pole in a chip's tape-out schedule. There are unparallelizable aspects that limit how fast a design can be completed. In summary, analog costs are ballooning, and analog is the time-to-market bottleneck. Why has analog escaped automation and remained a largely bespoke, human-driven activity? Well, it seems to be immune to classic computational methods, which simply cannot tame the enormous design space to find designs that align with manufacturing and reliability rules, while at the same time meeting circuit intent for power, performance, area, and cost. Only highly trained analog and layout designers, along with their hardened, earned intuition, ingenuity, and a lot of effort, are able to achieve these goals. In fact, automated analog layout is such a long-standing problem that it has become the holy grail of EDA. In order to reach the grail and avoid the grave, at Astrus, we've approached the problem with new, modern techniques to create AI-automated, physics-aware physical design. We take the traditional input from an analog designer and automate the creation of layout. The inputs to our system are schematics and rules of the game that Astrus AI uses to guide layout generation. Our approach is inspired by the same technology lineage that was used in AlphaGo. AlphaGo is the solution to a problem similar to layout, but in the board game of Go. Just like analog layout, Go is intractable to classical algorithms, and it was thought that only highly trained humans could play it at a high level. But AlphaGo bested the grand champion of Go. Our AI similarly creates layouts akin to a highly trained human, and it also turns days of human effort into minutes or hours. Similar to AlphaGo, Astrus learns through self-play. This self-play is within the immutable world of semiconductor layout, constrained by the laws of physics. This training through self-play is the key that unlocks the traversal of the high-dimensional layout space. Self-play allows learning of intuition about the game of layout. In fact, our system is similar to a second generation of AlphaGo called AlphaZero. AlphaGo training was kickstarted using a database of expert Go games and then launched into self-learning. In contrast, AlphaZero eliminated the expert kickstart and started training at the zero level and actually surpassed AlphaGo this way. Similarly, Astrus trains from zero and learns exclusively through self-play exploration. Let's take a closer look at the game of layout and its rules. We have two kinds of rules in the system. The first is that of hard constraints. These constraints being the schematic and DRC and LVS cleanliness and meeting all layout requirements in order to be tape out clean. These are the rigid, unbreakable rules of the game. The second kind of rule is the flexible constraint, which acts more like a target. These targets are provided by the analog designer in the same way they would be to a human layout designer. The AI, using its understanding of the hard constraints, layout rules, and parasitics, strives to meet these targets, while also achieving balance between the targets. We have found that the resulting layouts from this system can meet and in many cases exceed that of human layout. How can our system improve the overall analog design process? In a logic node, a high-performance analog subblock takes many layout iterations to finalize and sign off for tape-out. The well-known loop is to produce a layout, extract, simulate it, then debug the problems and come up with targeted layout updates to fix these problems. Common problems include violations of electromigration limits and not meeting performance or matching targets. Large changes, especially after the initial layouts, are risky, so instead a process of repeated, limited scope improvements is used to lower incremental risk. Although this approach increases the chances of convergence, it adds significant overall delay. Here we show a large design and how it might contain 8 blocks of varying complexity. Each of these blocks is iterated through the design process until all are completed. Parallelization is only possible up to the limit of the number of layout designers available. Their context switches are costly, since design context is not reusable between blocks. Each block has its own special requirements, driven by its functions. Using Astrus automated layout, we see a dramatic reduction in time to completion. Our system reduces both the time for an individual iteration to complete and also reduces the number of iterations because the quality of each iteration is higher than incremental human updates. And the system doesn't suffer from context switching overhead that humans do. Since it can hold all constraints in context simultaneously, the scope of updates can be as large as needed. Now a little bit about how our system aligns with our customers' data ownership requirements. We deliver the pre-trained AI know-how, and our customers own all the inputs and outputs, which can be used as they see fit. Because the AI is pre-trained by self-play, it is immediately useful, and there is no IP risk of reproducing a competitor's layout. Layout generation is driven by customer guidance in concert with the AI's self-learned knowledge. Further, we follow the strictest industry security protocols in order to meet foundry-grade security requirements. Finally, we hope you know a little bit more about how Astrus is building the physical design layer for AI-era analog design. We have a variety of open roles at Astrus if you find this work interesting, and we would love to hear from you if you are bottlenecked by analog design and layout. Thank you.